Hello. In this lesson, we're going to recreate the problem that we did in class to find all the information about a midsegment for a triangle. So, we're going to do our coordinate proof following these 4 steps. So step 1 was to draw a scalene triangle ABC, and we want segment AB to be on the axis. So I'll put point A right here, and A will be at the coordinates 0, 0. We'll put B on the x-axis somewhere. Now we don't know what B's coordinates are. We just know we went over to the right some amount. So what I will do is I will call B A, 0. We went over an amount. We don't know, so that's why we called it A, but we went up and down nowhere. Okay, so we know the length from A to B is A units. Now, ABC needs to be scalene per the information up here. So when I put C on this grid, I don't want it to be anywhere in the exact middle between A and B. So I'm going to put C off to the side a little bit here. That'll be point C. And so I can draw from A to C and then from C to B. Now, we can call C, we don't know how much we went over, we don't know how much we went up, so I will just call it B, C. All right, so part A is now done. Part B, we want to find the coordinates for the midsegment of AB through sides BC and AC. So to draw this, we want to find the midpoint of AC and the midpoint of BC. And I will call those points M and N. Well, how do we find those 2 points? Well, the midpoint formula is where we add our x's together, divide by 2, and then we add our y's together, divide by 2. So the coordinates for M, well, we'll add 0 and B together, B plus 0, and then divide by 2. Then we'll add our y's together, C plus 0, divided by 2. So M is at B over 2, C over 2. B plus 0 is just B, C plus 0 is just C. Let's find N. For N, we add our x's together. A and B, our x's, added together, divided by 2. Then our y's. Add 0 and C, and divide by 2. Now, there's no simplifying that first part. A plus B are not like terms, so we just have it as A plus B over 2, comma, and then the other part is still C over 2. Okay, part B, now done. Those are the coordinates of our endpoints for the midsegment. In part C, we want to find the slope. If you remember the slope formula, we subtract our y's, so y2 minus y1, over x2 minus x1. Now the slope for AB, we're going to subtract our y's, so 0 minus 0, then we'll subtract our x's, a minus 0. So we get 0 on top from 0 minus 0. The bottom becomes a. It doesn't really matter what the bottom is as long as it's not 0, because the top's 0. So if you have an amount of something, and then you take 0 of that amount, the amount that you have is nothing, 0. Same idea for MN. We'll subtract our y's, so C over 2 minus C over 2. Then we'll subtract our x's. That's A plus B over 2 minus B over 2. Well, the top is a number minus itself. Again, that's 0. The bottom, we have a fraction, and our denominators are already the same, so we can actually do the combine B minus B, which would cancel itself out. And all we're left with is a over 2. But again, it doesn't matter. We have a certain number on bottom that's not 0. So 0 out of something is 0. So the slopes of these are both 0. And that should make sense. We drew that so that they would both be horizontal. And so we can make a determination here that AB is parallel to MN because they have the same slope. That's part C. Now let's do D, the distance formula. For the distance formula, we subtract our x's and square, plus, and then we subtract our y's and square. So to find the length for A to B, well, we actually already found it. It's going to be A. But if I do the distance formula, we subtract our x's, so A minus 0 squared, we subtract our y's. And so we come up with A squared plus 0 squared, which is just the square root of A squared. And so we come up with A, just like we expected. For MN, well, we'll subtract our x's. So I'll do A plus B over 2 minus B over 2 squared plus C minus 2, excuse me, C over 2 minus C over 2 squared. Well, again, that's 0, so it's nothing. And again, here, the b's cancel. So we end up with the square root of A over 2 squared, or just A over 2. So the length that we get here for MN seems to be half the length of AB. Because the length from A to B was just A. The length from MN is A divided by 2. So we can make another determination that MN is half AB. Okay, so we've done all 4 parts here. We made a determination. Our midsegment MN not only has endpoints that are midpoints of the sides, but it's also parallel to the base, and it's half the length of the base. Okay, that's our crash course on midsegments. For now, we're done.